Hello everyone, welcome again. This time we are going to learn new chapter, that is chapter 8. It is continued with unit 1 for class 11 computer science with Python. Okay, and the name of the chapter is data handling. Previously we have learned so many things about Python programming languages. We have learned that what is a Python programming language, who has developed it, when it is developed, what are its advantages, disadvantages. Then we have learned what are different modes to write programs in Python programming language. Say for example, script mode, interactive mode, so many modes are there to write programs in Python programming language. Then we have learned different types of parts of Python programming, statements or commands, tokens. About tokens we have learned. Okay, and then we have learned other things like what are comments, what are keywords, what are different naming rules. Okay, so many things we have learned in the previous topic. Okay, and then we have also learned that how to write programs in Python programming language. Okay, from which statement we have to start. Okay, how we have to start Python programming language, writing Python programming language. Then we have learned the basic structure of the Python programming language. Then even we have learned and seen some sample programs and how the output will come, what are print statements, how we can do some mathematical works to calculate area of circle or so many things. And also we have done some exercises for our practice. Now we have come to learn more about these things, and this chapter deals more about Python programming language. And after learning this chapter, we will understand so many things and we will be very much familiar to write programs in Python programming language. See there are some fundamental building blocks. There are some fundamental building blocks of Python programming language. As anything is having some fundamental things, basic things, so Python programming language is also having these basic things. And what are those things? It is having data types, then variables, then operators and expressions. These are the basic things. Even the simple program or the smallest program we write in Python program, these fundamental building blocks is very much needed there. Okay, now we are going to learn data types. Python provides a predefined set of data types for handling the data it uses. Actually, when we have to write programs, we have to deal with data, different types of data, sometimes numbers, sometimes names, sometimes addresses. Okay, so many different types of data we have to handle while writing the program, while working with the Python programming language. So Python what it does, it divides different types of data in different categories. Okay, and these different categories are known as data types. A program also needs a means to identify stored data. Okay, actually these data types helps Python programming language to understand which type of data we are going to handle or which type of data is going to be processed. And data are of many types. Data can be of many types. For example, character, integer, real, string. So many types of data are there. Since the data to be dealt with are of many types, so Python provides ways and facilities to handle all types of data. See, Python has these core data types. What are core data types? See, these are numbers, sets. Okay, then none is a special type of data, that is none. Then sequences, then mappings. And numbers in Python, there are several types of numbers type data are available. integers are there, floating point numbers are there, complex numbers are there, and booleans are there. Booleans are almost treated as integer type data. We will learn these things in coming topic. Then sequences are there, strings, tuples, and list and dictionaries. So many things are there. Okay, we have to learn one by one. Now first we are going to learn about number data types. Okay, number data types are used to store numeric values in Python, and it is of following types. See, the number data types are how many types? Numbers are of three data types, basically three data types of number types: integers, floating point numbers, then complex numbers. And integer numbers are of two types in Python programming language, that is integers, which may be positive number or negative number also. Okay, positive number, in positive number we need not to put plus symbol before the number, but in a negative number we have to put minus symbol before any number. Now booleans are there. Booleans are having only two values, true or false. Okay, 0 or 1, like this. Now come to integers. Learn integers here. Integers are whole numbers such as 5, 39, 97, 0, etc. are the integer numbers. They have no fractional parts. They have no fractional parts. Fractional parts mean decimal part. Okay, these are whole numbers like 4, 5, okay, 61. These type of numbers are known as integer numbers. Now integers are represented in Python by numeric values with no decimal places. We need not to put any decimal places, not even 0.0. Okay, it can be positive number or negative number. For negative number we have to put minus symbol, and for positive number we need not to put any symbol. If we put symbol, there is no harm. Okay, we can also put plus symbols, and also we can put minus symbol, but for negative number minus symbol is must. We have to put minus symbol, must. But for positive number we need not to put plus symbol, it is not necessary. Okay, the number which is having no sign, it is treated as positive number. Now there are two types of integer numbers. First is known as integers, and next is booleans. Integer numbers, it is a normal integer representation of whole numbers. Integers in Python can be of any length. In Python language we can put integer number of any length. It may be 2-digit number, 1-digit number, or 100-digit number. There is no problem with the Python programming language. It is only limited by memory available. Okay, now it depends. If we put 100 numbers, 100-digit numbers of integer number, then there may come problem with your computer system if computer system is having less memory. So if having sufficient memory, then there is no problem with integer type numbers of long digit numbers. It is signed representation, that is the integers can be positive as well as negative number. Okay, now booleans, these represents the truth values false and true. Okay, how we have to write? For false we have to write false. So you can see here the first letter of false must be capital and first letter of true must be capital. Okay, so true and false, only two values are there. That's why it is known as boolean. Bool means also by, from the word by it comes boolean. Okay, then boolean type is a subtype of plain integers, and boolean values false and true behave like values 0 and 1. Okay, in Python 0 is treated as false and 1 is treated as true. Okay, so booleans data type comes under integer data types. That's why it comes in integer data types. Next is floating point numbers. Floating point numbers means the numbers having fractional part or the decimal part is known as floating point number. For example, you can see 3.14159, that is the value of pi, is a floating point number, and the decimal point signals that it is a floating point number, not an integer. If any number is having decimal point, okay, say for example 4.5, you have put 4.5, Then if there is decimal point, then you can treat it as floating point number. Okay, it is not an integer, it is a floating point number. Now floating point number can be written in two forms. There are two ways to write floating point numbers. First is known as fractional form, that is normal decimal notation. This is a fractional form. Okay, 4.5, 6.8, 6.952, okay, 3.14159. These are the numbers which are written in normal form, that is fractional form. Now these numbers can also be written in exponent form. First, see the examples of fractional form. Okay, 3500.75, 0.0005, 147.9101, etc. These numbers are there. Then exponent form. Exponent form is there, 3.50075 E03. Now the same number is written in exponent form. You can see here the same number is written in exponent form also. This number 3500.75 is in fractional form, that is normal form, and this number is written in exponent form like this. Okay, what we have put? We have put this decimal part this decimal part we have had put after 3. Okay, 3.500, then 75. Means this decimal part we have put 3 places back. That's why we have to we have written E03. E03. It means what it means, 3.50075 E03. It means what it means? It means that this number is written like this, 3.50075 into 10 to the power 3. 10 to the power 3. Like this number is written, 3.50075 into 10 to the power 3. Then if we process these values, these numbers, then it will become the number like this. So same number can be written in power of 10, in the value power of 10, and that is known as exponent form. But in Python we have to write in place of multiply symbol and 10 to the power 3, we have to write E symbol. Okay, E03 means 10 to the power 3. It is this number is multiplied by 10 to the power 3. So any number can be written like this. Say, see example here, 0.005 is written here, 0.5. Okay, this decimal places is put 3 places forward. So the exponent value E is multiplied by -04. Okay, -4, and the same number again it is written and expressed in exponent form like this. 147.9101 is written as 1.479101 e to the power 02. Okay, so any number can be represented in any two form, and both forms can be handled by Python. Okay, now next, what are the advantages of floating point numbers? Suppose we have express some numbers in floating point numbers, then what are the advantages? Floating point numbers have two advantages over integers. First advantage is that they can represent as values between the integers. Between the integers means, say for example 4 is there and 5 is there. Okay, two different numbers is there, and in between we want to put some numbers. That is possible with the floating point numbers. We can write 4.5, which comes in between this. 4.2 we can write like this, 4.1. okay, 4.110 like this we can put. Okay, these numbers, all these numbers comes between these two 4 and 5 numbers. So any number can be written. Next is they can represent a much greater range of values. Okay, so greater range of values comes here in floating point numbers. Next, one disadvantage is also there. What is that disadvantage? These are usually slower than integers in operations while processing, while doing mathematical calculations or doing some expression calculation. Then floating point numbers process slowly. Okay, it requires more time as compared to integer numbers. Okay. Now, next one is complex number. Python is versatile language that offers you a numeric type to represent complex numbers. So Python is very much versatile that it can also possible to represent numbers in complex numbers. Complex numbers are mostly used in engineering works. Okay, so mathematically a complex number is a number which is a form of a plus bi. A plus bi means first number is there, then plus symbol is there, then next number is there, and then one symbol is there, that is I symbol. Okay, where I is the imaginary number equal to the square root of -1. Okay, here I equals to what? It is equal to square root of -1. Square root of -1. Okay, I, and it is an imaginary number, that is I square equals to -1. It means if we calculate these things, then it will become I square equals to -1, like this. Okay, I square equals to -1. So the value of I is root under -1. If we square it, then it will become -1. So Python represents complex number as a pair of floating point numbers. Okay, though both the numbers a and b can be of floating point numbers in the form of a plus bj. Okay, in engineering, in mathematics, we have to write the numbers, complex numbers like this, a plus bi, but in Python we have to write j in place of I. We have to write j, means it is in the form of a plus bj. Okay, in place of I we have to write j. This is in Python. In Python we have to write in place of I j. That is, to represent imaginary number, Python uses j or capital J in place of traditional I. So in Python j equals to root under -1. For example, see example here, 0 plus 3.1j. Okay, 0 plus 3.1j, b equals to 1.5 plus 2j. These are the examples of complex numbers written in Python language. Okay, so Python language can handle complex numbers also, and it should be written like this. Now we have put all the number data types here, and we have to know what are the range of these numbers. See, first integer data type, it is having unlimited range subject to available of memory. Okay, virtual memory. What is the memory is there? Next is booleans. Booleans have only two values, that is true and false, and it is true is treated as 1. Okay, integer 1 number, and false is 0. Then floating point numbers, it is also having unlimited range subject to available of virtual memory or the machine architecture. And next one is complex numbers, same as floating point numbers. It is having also unlimited range because the real and imaginary parts are represented as floats. Okay, so any number can be put any number of digits. Now strings, next data type is string. A string data type lets you hold string data. It means string data means any number of valid characters, into a set of quotation marks. Within quotation mark, okay, within quotation mark we can put any value. It may be alphabet A, it may be number, it may be symbol. Okay, any number we can put, and this will become a string in Python. Okay, on strings we cannot do any mathematical calculation, okay, arithmetic calculations. So these are known as strings. Strings are helpful to put values like names, addresses, okay, even phone numbers we can put in strings, okay, sentences, text, these things we can put in strings where no mathematical calculation is to be required to be done. All strings in Python are sequences of pure Unicode characters. Unicode characters means we have already know that what is ASCII characters, what is Unicode characters. Unicode characters means the most common languages of the world we can put within this quotation. Even Hindi we can write within quotation marks, okay, in strings, and represents Hindi also. A string can hold any type of common characters, that is letters, numbers, special characters, or any known scripted language. Here see example here. Okay, so many examples are there. Okay, ABCD within quotation mark we can put double quotation mark or single quotation mark. There is no harm, but one thing is to be ensure, if we are using double quotation mark at the starting, then end must also closed with double quotation mark, okay, and if we are putting single quotation mark, then it must be closed with single quotation mark only, okay, then it will work. See here ABCD 1 2 3 4, these are all string, example of a string. Some symbols is there, okay, these are the string data type. Now next, string as a sequence of characters. Now how Python language process these string data type. See, Python string is a sequence of characters, sequence of letters, sequence of symbols, sequence of mixed of these things, numbers, symbols, alphabets, and each character can be individually accessed using its index. Okay, the index, also called subscript, is the number position of a letter in the string. Strings in Python are stored as individual characters in contiguous locations with two-way index for each location. Two-way index means it may be positive index numbers and negative index numbers also for each location. Hence, index begins with 0 onwards in forward direction and -1 -2 in backward direction. See example here. Suppose we have we have assigned a value Python as a string. Suppose s equals to, we have put s equals to a single quotation, within single quotation Python, like this, okay, like this. Then if it is stored in computer memory, how it can be stored? See, it is stored in contiguous locations, and each location is each letter is having an index number from 0 in forward indexing, 0 1 2, like this, 0 1 2 3 4 5, okay. The last sixth digit, sixth character is having the index number 5, okay, and the first character is having the index number 0. Okay, in the similar way, negative index from backward is also, the last character is having -1, okay, 5 is also there and -1 is also there. Both index number is valid for this last character, and it comes in backward direction, okay, like this. This is the backward indexing, and the values can be accessed like this. If we want to access 0 location value, then we have to write name 0, then it will give you the letter P, the first letter, or you can write name -6, the same letter will be given. Okay, similarly we can do like this, and we can write like this. Okay, all letters are given some index number, some index value, and 2 index value for each character is given. First is positive index number, and next is negative index number. Okay, now accessing individual characters of a string. Suppose if we want to access, if we want to print, if we want to display, if we want to process, if we want to work with single character, indivisible character of a string, then how we can do like this. Okay, first we have to give a string name and then index number. Okay, suppose we have created one string sub subject, sub equals to computer. The word computer we have put within single quotation mark. Then the memory will be like this, memory is occupied like this, and each letter will be given index number, positive index number and negative index number like this. And then if we want to access some letters, some characters, individual characters, then we have to write like this, sub0. sub0 we have put, then it will give you the first character, that is C. Then sub2 it will give you second, and similarly if you put sub-1 negative indexing like this, it will give you O, and if you put sub-8 it will give you again the first letter, that is character C. Okay, like this you can access any letter either using indexing number or forward indexing number or backward indexing number. Now, some facts about string in Python. The length of a string variable can be determined using function length. If you want to check the length of the string, then we can use this function, length function. Okay, you cannot change the individual character of a string in place by assigning, because strings are immutable. Once what is there, it is inchangeable. Immutable means we cannot change. If once a variable, a string variable or a string data is created, if we want to change using Python programming language constructs, then it is not possible. See example here, name equals to hello we have put, and letter after assigning value, okay, after generating, after defining a string, literal string data, next time we want to do any changes, then suppose we have written like this, name 0 equals to C, then we are going to here change the first letter H to C, but it is not possible. This will give you error because it is immutable data type. And what is some in Python language, actually some data type are mutable and some data type are immutable. Immutable data type once is created, it cannot be later change individual letters. Okay, we cannot change. So hence item assignment is not supported. However, if we want to do some changes, we have to change the whole word or whole string at a time. It is possible, but individual letter, if you want to change, it is not possible. However, you can assign. However, you can assign to a string another string or an expression that return a string using assignment. Okay. Now we can do like this. If you want to change individual character, then we have to change the whole string like this. Name equals to hello, name equals to cello. See, the first letter we want to change, but we have to change, we have to write the whole word as it like this. Then it will give you no error. Okay, and the word will be changed to from hello to cello. Okay. Lists and tuples. There are another two different types of data type in Python, that is list and tuples. They are almost same, but some difference is there. The list and tuples are Python's compound data type. They are basically the same type with one difference. List can be changed, modified, that it is mutable, but tuples cannot be changed or modified, that is immutable. Tuples are like strings. We can put values there, but we cannot change its individual values. But in list it is possible. It is mutable data type, and if we want to change individual element, individual data in a list, we can do changes. Okay, it is possible in list, but in tuple it is not possible. List. A list in Python represents a list of comma separated values of any data type between square brackets. Now understand the purpose of list and tuples. Why this type of data type is given in Python. Numbers data type are there. So many number data types are there. Numbers, floating point numbers, complex numbers, booleans are there. But they at a time they can hold only one value at a time. In a single variable we can put any single value only. So if we want, sometimes we need to work with more than one values. Okay, list of values, list of 10 values, 5 values, 100 values, we have to deal with these things. Then for that purpose Python has given additional data type, that is list and tuple. Okay, so a list in Python represents a comma separated value of any data type between square brackets. If we put values between square brackets separated by comma, then it will become list. Okay, and we can put any type of value within a square bracket separated by comma to make a list. It may be numbers, it may be text or letters, or it may be combination of both. Okay, it may be combination of both. See, okay, we have put here 1 2 3 4 5, the numbers we have put within square brackets, and then here letters we have put within single quotation mark. Then we have mixed those things, numbers and letters also. Okay, names also given. So a list can contain any type of value. Now variable assignment and accessing individual elements of a list, it is possible with list. And how can we do all these things? See here, we have put a equals to 1 2 3 4 5. Okay, values put. Then we have given print a, then the same is displayed here, it is displayed. Okay, now we are going to change the individual value of a list. It is very easy, just we have to put the list name, that is a, and within a square bracket we have to give the index value, index number. Okay, index number of that individual number or letter or character which we want to change, that index number we have to give. And we know that index numbers are starting from 0 1 2 3 like this, and also it may be in negative indexing also, -1 -2 like this. Okay, whichever index number you need you can give here. Here we have given, we want to change the value 1 to 10, so we have given a0 equals to 10, and a2 2 we want to change to 20, a2 30 we have to given, we have 30 given. Then we have print here, print a, then how it is displayed like this, 10. First number 1 is changed to 10, then second one is same, and third one, so index number of third one is 2, 30 is given, to 30 is from 3 it is changed to 30, then 4 and 5 like this, it is same. Okay, so individual letters can be changed in list. Now come to know about tuples. Tuples are represented as a group of comma separated values of any data within parentheses. Only difference is there, we have to put, if we want to define tuples, then we have to put within brackets. Okay, within parentheses. Okay, see here we have given 1 2 3 4 5 within a small bracket, that is known as parentheses. So it is a tuple. Okay, we can put numbers also, characters, any type of data we can put here. We have put here letters within single quotation mark separated by comma, and mixed type we have put. Now variable assignment and accessing individual elements of a tuple. See here what happens. Here tuple we have created, t equals to like this, then we have print, it is displayed like this. Then we have print the first value of the tuple, t0, then 1 is displayed here, and the third value t2 is 3 is given. And if we want to change any individual value, it is not possible with tuple, so it will give you error if you try to do these things. One thing is to be noted here, value of type list are mutable, changeable. One can change, add, delete a list element, but the values of tuple are immutable, not changeable. One cannot make changes to a tuple. Okay, once it is defined, we cannot change individual value. Okay, however, if we want to change the whole tuple, whole numbers, all the numbers at one time, then it is possible. Okay. Now, then next data type in Python, which is available in Python, is known as sets. Sets are also similar to lists that can store multiple values, same as mathematical sets, but Python sets are little different from lists. Some is different is this. These differences are like this. Sets are created by specifying comma separated values enclosed in curly braces. Okay, what type of braces? We have to put curly braces, and within these we have to put values separated by comma, all the values separated by comma. Then it will become sets. Okay, sets elements are unordered and unindexed, unlike list. Okay, there is no ordering. Okay, also there is no indexing. Indexing is also not there. Okay, sets do not allow duplicate entries, unlike list. We cannot put duplicate values. Okay, same two values in a set. It means that set must have unique values. All values must be unique. Okay, different from another values. Sets, but in list we can put duplicate values. Sets do not allow duplicate entries like list. Sets cannot contain mutable elements. However, a set itself is mutable. We can add or remove items from it. Okay. One major thing is that, okay, we can put we cannot contain mutable values in a set. It means that we cannot put list in a set. List data type cannot be inserted, cannot be given in set. Okay, only immutable data types, immutable data can be put within set. See example here. Okay, see, we have created s equals to, within curly braces, 1 2 3 4 1 2 3 4. This is s will become set, and we have displayed it 1 2 3 4, and then s1 equals to 1 2 3 4 4 we have put here. 2 times 4 we have given, it will give you error. Okay, here is mistyping, so only 3 4 5 you can give here, or and up to 4 you can give. Print s1, then 1 2 3 4, it is displayed. We have put 2 values here, but it stores only one instance of that value. 2 values we have given, one will be ignored by set automatically, and only one value will be given. Understood? So no duplicate values it will kept. And if you want to change individual value, it is possible with sets, as like list. It is possible. Now next one is, that is the last data type of Python language, is dictionary. The dictionary is an unordered set of comma separated key value pairs. In dictionary we have to put values in pairs, okay, with curly brackets, with the requirement that each key value pair should be unique and cannot be same. Each pair must be unique, just like sets. Sets keep you unique values. In the similar way, dictionaries also wants to have unique values. For example, you can see vowels we have created here. Dictionary, and we have put values in pairs here, and each pair must be separated by colon, and each pair must be separated by comma also. Okay, see here, A1 we have given, E2 we have given, I3 we have given, 0 O4 we have given, U5 we have given, and this types vowels is displayed. And if we want to print, it will display you same. And if we want to display the first value, then indexing is not possible here. Indexing is not given here. Instead it gives you keys and value pair, and using keys you can display the value. Here A is treated as key, A, E, I, O, U is treated as key. The first value of the pair is treated as key and the second value is treated as value. Then when you give key, then it will display you value. Okay, you have given 5 like this. Okay, now Python data types are strings, list, tuples, dictionaries, sets, etc. are all iterables. Iterables means an iterable in a Python object that can return its members one at a time using their index number or key value. Iterable means we can use iterable statements like for or while. For statements we can use with these dictionary data type or these iterable data types such as a string, list, tuple, dictionary, sets. Okay, and we can print individual values using that one by one. It is possible. Mutable and immutable data types. However, we have learned earlier what is mutable and immutable. Now we are going to learn more about these things, mutable and immutable data types. Mutable means modifiable, changeable, okay, and immutable means non-modifiable, non-changeable. We cannot change individual values in place. See here, mutable and immutable data type. Python data object can be broadly categorized in 2 types. All data types which are available in Python language, it may be string, list, tuple, dictionary, sets, okay, integers, floating points, booleans, all can be categorized under these 2 different types: immutable and mutable, non-modifiable and changeable modifiable types. See here, what is immutable data type? We already know immutable data types are those data types which never change their value in place. Never change their value in place. In place means individual value. Okay, in Python the following are immutable data types. See here, integers are immutable, floating point numbers are immutable, booleans are immutable, strings and tuples are immutable. It means we cannot change its individual value in place. Okay, in Python variable names do not store values themselves. Do not store values themselves. That is, they are not storage containers. Rather, the variable names are just the reference to value objects or data objects. Actually, suppose the variable a is given 5. As a here 5 is integer number and a will become immutable data type, and immutable data type says that the value of a cannot be changed later. If once it is created, once it is defined, it cannot be changed. But if we write somewhere after a equals to 6, then a will hold 6, means it is changed. You will see that it is changed, but actually it is not changed. There is some thing in Python. Actually, Python stores values differently. Variable names, that value a and b, the variable names is given here, a or b or c, like these variables do not store or do not hold these values. Actually, instead, what is that? These values are already stored in memory and the variables are created as the reference to those values, reference to those variables, okay, a pointer to those values. These are the pointers to those values. Means these values are already stored on memory and some address is given for those values, and whenever we give the variable name, these variable names just reference those variables which is already stored in the memory, and memory address is assigned to those variables. And later, if we assign different values, then different address is stored with the variable a. See here, variable names do not store values themselves. They are not storage containers. The variable names are just the reference to value objects or data objects, just the reference, just the link, just it is a link, just it is a pointer for those values. You can see example also. First you listen, first you read this. Thus it is clear that variable names are stored as a reference to a value object. Each time you change the value, the variable's reference memory address changes. Variables of certain types are not like storage containers. They are having a memory address where value changes every time, hence they are immutable. Okay, see here example also. We have defined three different variables p, q and r. P is assigned 5, q is assigned p. Q is assigned p, means the value of 5 which is already assigned by p is assigned with q, and r is assigned with 5. Now when we print all three variables, then it will give you value 555. And once you see the ID, means the address, memory address of those variables or the value, see what is that address is given here. ID of p, ID of p is displayed like this, and the 4048, the address is 4048, and then ID of q is displayed same 4048, and ID of r is also given 4048, and ID of 5 is given same 4048. How it is possible? Because the 5, actually the number 5 is stored at that address, and whenever assigned a variable here, variable name here, some name is given to those values, then those names are just become the reference for the value which is stored at that point, at that memory address. So the value 5, whichever the variable will contain the value 5, it will reference to these addresses only. Hence it is understood that the it is not changed. Okay, same memory address is there. It means it is not changing. It is not changeable. Then it is immutable data type. Okay. Now, mutable data type means changeable, modifiable data type. Mutable data types are those values that can be changed in place. We can change. Only three types of mutable data types are list, dictionaries and sets. Only three types are available in Python, which are mutable data types, list, dictionaries and sets. And list to make changes, there is easy for this. Here we have created a list and we have changed the second value, the index number 140, and then we have printed, then the value is changed here, 40 is changed, 4 is changed here. Okay. Now next topic we have come again, that is variable internals. What are these things? You can understand. Python is an object-oriented language. It calls every entity that stores any value or any type of data as an object. Every Python object has three key attributes associated to it. And what are those three attributes? First is the type of an object, the value of an object, and the ID of an object. What is the type of an object? Determines the operation that can be performed on the object. If the type of data is integer, then we can do arithmetic calculation. If it is a string, then we can only those operations which can be handled by strings only. So built-in function type returns the type of an object. If we want to see type of any data or any variable, then we can use this function type function. For example, like this. Okay, see, if here a equals to 4, if you want to see the variables a type, then we can write like this, type within bracket a, then it will display that it is integer type. Okay. Now the value of an object, if we want to, value means the value it is contained. The data item contained in the object. For a literal, the value is the literal itself, and for a variable, the value is the data item. It is controlling referencing. Using print statement, you can display value of an object. A equals to 4, then print A, it will display you 4. Now, ID of an object. The ID of an object is generally the memory location of the object. Built-in function ID returns the ID of an object. Okay, it will give you the ID like this. ID means the memory. Actually, each and every variable is having three different values, and first is data type, second is the value itself, and the third is ID, the memory address. Okay, three things are associated with each and every variable in Python language, and all three things we can display. We can see the type, we can see type using the type keyword or type function. Value can be displayed using print function, and ID or the memory address can be displayed using ID function. Now we have come to operators, learning operators. Now different data types are assigned with different types of operators, different types of operations. Depending on data types, we can do operations on those data types. If a data is integer type, a number type, we can do arithmetical calculation. If it is string type, we cannot do arithmetical calculation, but we can do some other types of calculation. So data types defines which type of operation can be performed on which type of data. Similarly, operators allows us to do particular operations on those data, and depending on the type of data, the operators changes its behavior for those data types. We can see later. The operations being carried out on data are represented by operators. The symbols that trigger the operation action on data are called operators. The operations specific tasks are represented by operators, and the objects of operations are referred to as operands. Python is having following types of operators. Arithmetic operators, relational operators, identity operators, logical operators, bitwise operators, membership operators. These are the operators. Okay, so many types of operators are available in Python language. Now, one by one, we are going to learn arithmetic operators. To do arithmetic, Python uses arithmetic operators. Operators can be broadly classified as unary operators and binary operators. Unary operators means the operator which can handle one data at a time, and binary operators are those operators which can work on two data at a time. Okay. Now next, see here the symbol and the name. Example, result. Plus is there are unary operators. There are two unary operators in arithmetic operators. Two unary arithmetic operators. First is plus and next is minus. Unary plus and unary minus. Okay, plus and minus, like this we can define arithmetic operators. Now next is binary arithmetic operators. So many binary arithmetic operators is there. Minus for addition, plus for addition, minus for subtraction, then multiplication, division, modulus, and floor and exponentiation operators are there. Okay, see, plus for addition, minus for negative, and star is given for multiplication, and divide for slash, forward slash for division, and percent symbol can also be used in arithmetic operation for obtaining a remainder or the modulus. Okay, now double forward slash can be used for floor division. Floor division means it won't give you decimal places value. If you divided, suppose 10 divided by 3 you given, then it will display you output 3 point something, 3.33 like this. But if you give 10 double divided by 3, then it will give you only 3 value, 3.0 value given. Okay. Now double star is for exponentiation, for power. Okay, power you can use. Suppose you want to obtain 5, okay, to the power 3, then it will give you like this, 5 into 5 into 5. What is given? 5 into 5 into 5, which will become 25, 625. Okay. $125, sorry, it will give you $125. Now next, augmented assignment operators. Some operators are known as augmented operators. Augmented are just the shorthand technique of assignment operator. Python offers augmented assignment operators which combine the impact of an arithmetic operator and an assignment operator. Two operators are combined at one places. That is known as augmented operator. Here a equals to a plus b can also be written as a plus equals to b. Okay, a equals to a plus b can be also be written as a plus equals to b. Okay, here a is given 2 times, and in augmented, if you use augmented, then you have to give only 1 time the variable a, only 1 time. So other augmented operators are plus equals to, minus equals to, multiply equals to, slash equals to, divide equals to, power equals to, percent equals to. All operators can be done using this augmented operator, and these will perform like this. These operators can be performed like this. You can understand. Then relational operators. Relational operator determine the relation among different operands. Python provides 6 relational operators for comparing values, thus also called comparison operators. If the comparison is true, the relational expression results into the Boolean value true and Boolean value false if the comparison is false. The 6 relational operators are less than, greater than, less than equals to, greater than equals to, equals to, and not equals to. These are the different relational operators. Now see how relational operators work. Relational operators work with nearly all types of data in Python, such as numbers, string, list, tuples, etc. Relational operators work on following principles. For numeric types, the values are compared after removing trailing zeros, after a decimal point from a floating point number. Strings are compared on the basis of lexicographically ordering in dictionary. 2 lists and similarly 2 tuples are equal if they have same elements in the same order. Boolean true is equivalent to 1 and Boolean false is equivalent to 0 for comparison purposes. So relational operators, if you apply relational operators on these different types of data, then it will give you different results. Identity operator. There are 2 identity operators in Python: is and is not. Is and is not. The identity operators are used to check if both the operands reference the same object. Memory. Okay, that is, the identity operators compare the memory locations of 2 objects and return true or false accordingly. Identity operators are is and is not. 2 identity operators: is not. Say for example, A is B. Here what it does, it checks both A and B for the memory location, returns true if both its operands are pointing the same object, that is, both referring the same memory locations. Return false otherwise. Is not. A is not B. Usage. This, for example, It returns true if both its operands are pointing to different objects, means referring to different memory locations, or it returns false otherwise. See the example here. Okay, for example, a equals to b equals to 10. Okay, 10 is stored in a and b. Now it is checking a is b, then it will return true. Okay, as both reference the same memory address of value 10. Okay, this is the things identity operator is and is not. Next, logical operators. The relational operators are used to establish relationship among the values and the Boolean logic operators or and not. Actually, three relational operators. We can understand that what is relational operator. It gives us relationship between among two different values, and relational operators are greater than, less than, equals to, not equals to, greater than, equals to, less than, equals to. These are the relational operators. Suppose when we use or comparing more than one time using relational operators, then in between two relational operators or two relational expressions, these logical operators are used. And what are the logical operators? There are three logical operators, or, and not, that refer to the ways these relationship among values can be connected, or they can be connected. It determines, this logical operator determines both the relational expressions. Python provides three logical operators to combine existing expressions, and these operators are, we know that OR operator is there, AND operator is there, and NOT operator is there. Okay, now one by one we are going to understand it, how it works. See here, the OR operator. The OR operator combines two expressions which makes its operands. The OR operator works in three ways, these ways. See here how OR operator works. Okay, OR operators works with two relational expressions. Okay, see here how it works. Relational expressions as operands. Suppose if we are using relational expressions, more than one relational expression, and between those relational expression, to combine these two relational expressions, we can use this OR operator of logical operator. Okay, then what will happen? The OR operator evaluates to true if either of its operands evaluates to true. If either of the relational expressions are true, any one of the relational expression are true, then it will give you the complete true result. Okay, and the rest of the case it will give you false. Okay, what are the say for example here we are giving you 4 equals to 4 or 5 equals to 8. Here two relational expression is given, 4 equals to 4 first relational expression, and 5 equals to 8 second relational expression. Then both this first one will evaluate to true, but second one will evaluate to false, because 5 is not equals to 8. Then OR operator will return true. Why it will return true? Because it here it will return true. Why? Because out of 2, 1 is true, then it will give you true result. And the same next expression you can see, 5 is greater than 8, it is false, and 5 is less than 2. 5 is less than 2, it is also false. Then this time when both expression is false and OR operator is used, then it will return false. Only those cases. See here, okay, x, suppose x is a relational expression and y is also another relational expression, and both become false, then only it will give you false, and other cases it will give you always true value. Okay, this is the things. Or suppose when you are using numbers or strings or list and comparing both of them using OR operator, then what will happen? In an expression x or y, if first operand has false, then return second operand y as a result, otherwise return x. Means it will return the complete value, that a or b two value are there, or x or y two or value are there, and those values are not any relational expression, they are numbers, strings or list, and we are using OR operator, then what happen, it will give you the give you the value, okay, or the numbers or the strings. That expression it will give you is as a return. It won't give you true or false, it will give you the expression itself. See example here. Okay, x and y, suppose x is false, y is false also, then x or y will give you what? Y value will be given. This y value will be given. When both are false, then second value will be given. First is false, then second value will be given, y is given. If first is true and second one is false, then only x is given. Okay, and first is true, both are true, then this case also first value will given. Here in simple terms you can say that if the first expression gives you truth value, okay, truth value is 1 or more than 1. Okay, if this value is given you truth value, then first expression will be returned, and in other cases second expression will be given. If first is false, then only second will give. Both are false, then second will be given. Okay, see example here. You can see here, for example, 0 or 8, two number values are there. 0 gives you false, okay, then it will return 8. Okay, this 8 value will be returned. A or J, both are same value, okay, both are said to be positive value, then it will give you value A. The first value will be given, A is given. Okay, so accordingly you can use this OR operator. Now the AND operator, how it works. See, AND operator, these operators are used, we know that these operators are used where relational expressions are more than one relational expressions are there, then we use this AND operator. In Python we can use AND operator for other purposes, other data types also, numeric, string, list, like also. So both these two types, relational expression and other type of expression, in both cases this AND operator works differently. See here, the AND operator combines two expressions which make its operands. The AND operator works in these ways. See here how it works. See, relational expression as operands. The AND operator evaluates to true if both of its relation operands evaluates to true. False if either or both operands evaluate to false. It means that if both expressions are true, then only it will give you true, and in rest cases it always give you false. Okay, see here, false false, then it will give you false, false true false, true false false, any value or both value false, then it will give you the result false. Only it will give you true value when both expressions, both relational expressions are true. See example here. Okay, see example. For example, 4 equals to 4 and 5 equals to 8. Here first expression is true but second expression is false, then it will give you result false. Okay, here 5 is greater than 8 and 5 is less than 2, both are false, then again it will give you false. If both are true, then only it will give you true. Okay, see next, numbers. When we are using, how it will work with numbers. Numbers or strings or list as operands in an expression x and y. If first operand, that is expression x, has false value, false, then they return first operand x as result, otherwise return y. Here how can we determine that a number is false or a string is false or list is false or true? See here, if a number is more than 0, then it is treated as true, okay, and 0 is treated as false. In a string, if empty string is there, it is treated as false, and if a string is having any of the value, then it is treated as true. In the same way, list, if list is empty, then it will be treated as false, and if it is having any of the value, then it is treated as true. Okay, accordingly it will work. See, if the expression x has a false value and y has false value, it will return x. In AND case, it will return x. If one is false and other is true, it will again return x. And if first is true and next is false, then it will return the next one. The false one it will return, and both are true, then only it will return next value. Okay, both true, then only it will return y value. Okay, accordingly it will give you the result. See the example here. Both are false, 0 and 0, then it will return the first one value. Both are false, okay, then it will return x. X0 is returned, the first one value, which is 0, is returned. Here a and j will return j. See, both are positive value, a and j. Then when both are positive value, it will return you the y, means second one will be returned, that is j is returned here. And accordingly you can understand that how this AND operator is working. Okay, now next, this is the last logical operator, that is known as NOT operator. It is a unary operator. Unary operator means it works only with one operand. Okay, the Boolean logical NOT operator works on single expression or operand. It is a unary operator. The logical NOT operator negates or reverses the truth value of the expression following it. That is, if the expression is true, then NOT expression is false, and vice versa. If it is false, it will give you true. If it is true, it will give you false value. Okay, just it will negate or reverses the result. See the example here, how it works. Okay, not 5. Here what is given here? Not 5 means 5 is truth value, then it will return false value. False it will return. Not 0. Okay, it is false value, 0 is treated as false, then it will return you true value. Okay, not minus 4. Minus 4 is treated as in false value, then it will give you only 0 is treated as false value and the rest of the value is treated as true value. So not minus 4 will return false, because minus 4 is also treated as truth value, true value, then it is returned false. Here expression is given 5 greater than 9, it is false, it will return you false because 5 is not greater than 9. Okay, and NOT operator is given here, so it will return you true value. Okay, see, result will be true. Accordingly it will work. So understood, just NOT operator is an unary operator which works only with one operand, and it will return the reverse of that value. Now next here, see precedence of operators. So many operators we have learned: arithmetic operator, relational operator, logical operator, and so augmented operators. So many types of different operators we have learned. Now if an expression is having different types of mixed type of operators, then how it can perform, how it can operate, or it can evaluate the expression. Okay, we know in mathematics board mass is a rule. Okay, board mass is a rule. First bracket, then off means multiply, like divide, then multiply. This type of precedence is there in mathematics. Here in computer, this is the operator precedence. Okay, see here how what is the highest, having the highest precedence. Again, bracket, whatever is put it in bracket, this will give a higher precedence. Okay, it will be having the higher precedence, means it will be evaluated first in an expression. Okay, so next is exponentiation, and some other operators are like this. See, logical operators are given the lowest priority. Okay, it will be evaluated at last. Okay, and before logical operators there is a relational operators. So like this it will work. If relational operator, logical operator is there, logical operator will be evaluated first, and then logical operator will work. Okay, this is the precedence operator precedence chart. Now we have come to learn expressions. We have already worked with expressions so many times. Now we are learning that what is actually an expression. An expression in Python is any valid combination of operators, literals, and variables. If we combine these things, operator, literals, and variables, then it is known as expression. Say for example, x is a variable, plus is an operator, okay, literal 7 is a literal, and some variables, operators. Okay, see, this is variable, this is literal, this is operator. We have combined all these things. This is known as expression. Okay, this is known as expression. Okay, we are learning this, what is expression. Okay, an expression, again, an expression is composed of one or more operations with operators, literals and variables as the constituent of expressions. Okay, so what are the parts of an expression? Parts of the expression are operators, literals and variables. Okay, when we combine these things, it will become expression. The expression in Python can be of any type. So many types of expression can be defined. Okay, it depends on the operator we use. Whatever the operator we use, the expression will become that type of expression. If we are using arithmetic operator, then it will become arithmetic expression. See, this plus is an arithmetic operator, 7 is a number, so this expression is called arithmetic expression. Similarly, a string expression can be generated, can be defined. Relational expression, logical expression and compound expression can be defined. Okay, now the type of operators and operand used in an expression determine the expression type. Okay, the operator and operands, whatever the operands we use, it defined that what type of expression is that. If we are using arithmetic operator, arithmetic values, then it will become arithmetic expression. Similarly, an expression can be compound expression too if it involves multiple type of operators. Okay, we can use greater than symbol with plus symbol. So arithmetic expression is arithmetic operator is there, and also relational operator is there. So this type of expression is known as compound expression. You can see example. This is the example of arithmetic expression. A plus b greater than c okay, power d, or you can see a into b less than b c into d. These are the compound expressions example. Now next, so we have learned arithmetic expression. Arithmetic expression, it involves numbers and arithmetic operators. Relational expression, an expression having literals and or variables or relational operator is called relational expression. Example, x is greater than y is less than equals to z. These are the relational expression. Logical expression, where logical operator is used. An expression having literals and or variables and logical operators is known as logical expression. A or b, a and c, like this. A string expression, Python supports two string operators, plus and multiply. There are only two string operator, plus and multiply. Okay, if we are using these operators with string type data, then those expression is called a string expression. Okay, so a string operation like this with operator plus. And what are the uses of these operators with string? See, plus operator will concatenate operator, concatenation, joining of two string, it will work. Okay, we will show you example also. Now multiply operator, it replicates the operator. Replicate operator is known as replicate operator, and it replicates mean multiplies values. See example here. Okay, how both these operator works with a string. Plus, if we are using here two string value is there, string literal is there, and then plus is given here. Now what it does, it will join both the words in one expression, one string. Okay, this is known as concatenation. It will join. Plus means join. If we are using multiply symbol, then what will happen? It will multiply, means it will this word will be presented two times. See the result here. Two times and is given in the expression. This is known as replication. Multiplication 7 or asterisk symbol is for replication, multiplication, and concatenation. Plus operator is used for concatenation in string expression. Okay. Type conversion. type conversion, actually what happened, see, when in expression with mixed types, suppose we have used mixed type of values, operators, then in an expression, then this type conversion happens. Python internally changes the data type of some operands so that all operands have the same data type. Changes the data type. When we use different types of data, say for example, in an expression we have used integers and float type data. Okay, both data we are using in an expression. Then during processing, Python, what it does, Python does changes the operand, changes the type of all the data to same data type. Okay, it is necessary for processing, otherwise results will not give you the correct result. It needs, a computer needs these things. Okay, so all the data types are converted to one data type, same data type. Okay, so how it works, there are two types of type conversion. First is known as implicit type conversion, second is known as explicit type conversion. Okay, so understood why it happens. What is this type conversion? Actually, when mixed data used in an expression, mixed type of data, integer, float, complex, these types of, then this happens. Why it happens? Because Python wants to be all the data of same type to do the operations. Okay, to do the operations. For that purpose, two types of type conversion is available here, implicit and explicit. First is implicit type conversion. This type of conversion is performed by the compiler automatically without programmer's intervention. So we need not to worry about it, that how computer is working about it. Just we have to put expression, whatever we need. We just put the expression. We mixed different types of data, there is no harm. Okay, and everything will be done automatically by the Python compiler, by the Python language. Okay, by the compiler or the interpreter. See here, an implicit conversion is applied generally whenever differing data types are intermixed in an expression so as not to lose information. Okay, it is not to lose information, implicit conversion is applied. Okay, now in this conversion, Python converts all operands up to the type of largest operand, and so it is also known as type promotion. Actually, when suppose integer and float data type, two expressions we have used. Suppose we have given 5 and plus and then 6.3 like this. So 5 is integer number and 6.3 is the floating point number. Then what will happen? This both will be changed to floating point number. This 5 will be promoted to 5.0. Okay, 5.0. Then it will be added to 6.3 and then result will be given. Okay, so here in implicit type conversion, it is happen automatically, and all the data types, all the data is converted to the largest operand available in the expression. So it is also known as type promotion. Implicit type conversion is also known as type promotion. For example, if variables ch and I are of integer type and db is floating type, then the expression chi divided by db will result in floating type. And how it will be converted to floating type, see here. See, ch and I are both are integer type. Okay, and db is floating type. So both integer type are performed, addition is performed here, and result will be given in integer type. Now a floating type db is there, and both numbers will be divided. So two different types of data is here, so automatically this integer type will be converted to floating type, then both floating type numbers will be given and divided, and then result will be obtained in floating type. So in first step no conversion is here because both the values are here of integer type, same type, but in step 2 int is converted to floating point. Okay. So conversion is done where different data types are obtained. Okay, and it is happening automatically, we not to do anything to happen implicit type conversion. Now next, explicit type conversion. This type of conversion is user defined conversion that forces an expression to be of a specific type. Suppose in implicit type conversion, each and every expression or the values are converted to the highest or the largest data type. Suppose sometimes we need to demote the suppose two different data types are there, integer and float is there, and we want result in integer data type. Then what we have to do, we have to use this implicit type conversion system. Okay, so typecasting in Python is performed by function of appropriate type in following manner: data type and expression. Okay, what we have to do in implicit type conversion, we have to use this type of formula, this type of system. We have to give the data type and the expression to convert the whole expression to this data type. Okay, say for example b, we want to convert b to integer type, then we have to give like this. If we want to convert a to float type, we want to write like this. See example here, okay, to understand it in clear way. See here, fd and db, two different variables are divided here, both are float data type. Okay, so here both no conversion is given here, and then multiplied by ch. In ch is integer type, then here floating type result and integer mixed type of data is there. Then implicit conversion, it will integer will be converted to floating point and result will be obtained in float, and then again integer number is there and float result is there, so both again will become floating and result will be obtained in float. And suppose if we want this result in integer, then we have to write here what in front, here we have to write here int, then only the whole result will be converted to int data type. If we need this, we can write int data type, int word, to convert the expression in integer type. Okay, see here Python data conversion function. Several other data conversion functions are also available in Python. Okay, if we suppose from any number convertible types, suppose float or string having digits, any type of data is we are having and we want to convert it to integer, then this int function can be used. Okay, so again from any data type to want to convert in float point, then we can use float function. Okay, and okay, suppose number is there and we want to convert it to complex number, then complex conversion function can be used. If number is in boolean numbers and we want to convert it to string, then str function can be used. If any other type is there and we want to convert it to boolean, then bool function can be used. Okay, so there are 5 different functions, conversion functions, which can be used for different purpose to convert int to integer, float to float type, complex to complex type, and str to string type, and bool to boolean type. And see the example here how it can be used. Just we have to put the value within the brackets and we have to mention the data type. It will be converted to that data type, and this conversion is known as explicit conversion, explicit data conversion. One more important thing is there in Python, if the operator is the division operator, suppose division operator is there, the result will always be floating point number. if division is there, division operator we are using, then result will be every time the result will be in floating point number. If when we are using all the values of integer type, instead it will give you result in float data type. Okay, this is exception in Python language. So today we have learned so many things, different type of functions, okay, different types of data types, expressions, okay, different unary operators, binary operators, logical operators, so many things we have learned today. Implicit type conversions, okay, explicit type conversion, okay, different data conversion functions we have learned. Now it's time to do some exercises. So we have given you some exercises. Do it yourself and evaluate yourself that how much you have understood the topic, that is data handling topic. Thank you.